The western coast of Norway is home to some of the most dramatic landscapes on Earth. Carved by glaciers throughout the ages, some of these fjords stretch for 200 kilometers inland and over a kilometer deep. The current convoluted travel route through and around this terrain takes you along Norway's 1100-kilometer, 683 miles E39 highway, a road with a total journey time of 21 hours. Now, the Norwegian government are working to improve access to services and residential and labor markets across the country's western regions by embarking on the largest infrastructure projects in the nation's history. Norway's E39 highway runs between Kristiansand in the far south of the country and Trondheim in the north. The route navigates its way across the fjord network and features no fewer than 7 ferry crossings. The new coastal highway project aims to eliminate the need for ferry services altogether by building a series of bridges and tunnels across, through and under the landscape. With many of the fields along the route being too wide or too deep for conventional infrastructure to cross. Innovative new solutions are being investigated by the Norwegian Public Roads Administration. Rogfast is the first in a series of crossings that will link the E39 connecting Stavanger and Helgesen via a 27-kilometer, 16 miles undersea tunnel. This structure will reach depths of up to 390 meters below sea level, making it the deepest as well as the longest undersea road tunnel in the world. The Rogfast project will in fact consist of 2 tunnels connected every 250 meters with emergency exits. Each tunnel will have a levee at 500 meters intervals, along with telephone and surveillance cameras along the route. The tunnel will also feature a mid-route intersection with the island municipality of Kvitsøy, creating an undersea tunnel junction and connecting the island with the Norwegian mainland. With work begun in 2018, this element of the project is said to be completed by 2026 at a cost of $2 billion. While the Rogfast works are already underway, the scale of some other fjords is presenting the project team with extreme engineering challenges. Bjørnøy Fjord, located to the south of Bergen, stands 5 km wide and reaches depths of 600 meters. To cross this challenging stretch of water, a proposal has been put forward for a floating bridge anchored to the shore at both ends. The Sulafjord crossing has seen 2 possible solutions put forward. The first is for a 3-tower suspension bridge with 2 of the bridge's towers anchored on land and the 3rd central tower anchored to the seafloor, some 400 meters below the waterline. An alternative proposal for a submerged floating tunnel would see 2 interconnected tubes running side by side tethered to the seabed using high-strength cables. Crossing the Romsdalsfjord will require a 16-kilometer undersea tunnel, much like the Rogfast project from Ålesund to Midsound, followed by a 2-kilometer suspension bridge connecting onto Molde. By far the most complex and ambitious of all the coastal highway crossings is that at Senja Fjord, also known as the King of the Fjords. Norway's largest and deepest fjord is over 3.7 km wide and an incredible 1.3 km deep at its lowest point. While these extreme distances pose their own challenges, engineers must also account for the high number of ships that enter the fjord on a regular basis. Any crossing must allow for a clear shipping length that is at least 400 meters wide, with 70 meters clearance above the water's surface, and at least 20 meters clearance into the depths. To deliver this, the project team are considering numerous different types of crossing for this fjord. The first is a traditional suspension bridge with a 3,700 meters crossing. Such a structure would be almost double the length of the world's current longest bridge and would require support towers at least 450 meters tall, significantly eclipsing the 343 meters tall Malau Viaduct in France. To become the world's tallest bridge structure, a floating bridge is also being considered. However, this structure would need to raise to allow ships to pass, and achieving such a feature in a bridge that is only anchored to each shoreline poses considerable engineering challenges that are yet to be overcome. In a similar proposal to that found at Sulafjord, a submerged floating tunnel is also being considered. This proposal would differ slightly to its counterpart due to the extreme depth of Senja Fjord. Rather than being tethered to the seabed, the tunnels would be suspended from floating pontoons that would allow ships to pass overhead. A hybrid proposal is also being considered. combining a floating pontoon bridge with a portion of submerged floating tunnel that allows ships to pass. Whilst fixed bridges, transferring into fixed tunnels is not an uncommon solution in waterways with high shipping traffic, such as the link between Denmark and Sweden, and the extensive Hong Kong to Macau crossing. Combining the two floating structures in this way would create the world's first example of such a solution. Finally, a proposal for a multi-span cable stayed bridge is under review. This structure would feature 4 floating pylons tethered to the seafloor rather like oil rigs. With safety and environmental considerations being of the utmost importance, Norway's vast coastal highway project is set to become a new benchmark in engineering capabilities and a model for future infrastructure projects around the world. If you enjoyed this video and would like to get more videos similar to this, consider subscribing to our channel and we'll see you at the next one.